Guys, welcome to this amazing hackathon. You can see our poster right now. Yeah, it's so great to see everybody here. It's a full room. Um, we honestly didn't know what to expect. This is a one-of-a-kind hackathon we're doing, and it's connected to this conference as well, which a lot of you might know about. But first of all, before introducing the hackathon itself, I want to get to know the room a little bit. So, how many of us are from UCLA? Okay, a lot of UCLA people. First years, okay. Second years, third years. Okay, only two third years. I was a third year last year, guys. So fourth years, my fourth year family over there. Okay, I'm gonna. Anyways, any professionals from industry as well? Okay, we've got a lot of professionals as well. That's good to know. All right, so we're gonna introduce the hackathon. The team has worked very hard towards it. Karen has orchestrated and worked very hard towards it, so I'm sure she can introduce a little bit.
Great. Thank you guys so much for coming. Let me just put this away briefly. Okay. Hi, everybody. My name is Karen, and thank you guys so much for coming today and kicking off this week-long event of tech talks and then leading up to our SoCal AI Responsibility Summit. And today we're going to be talking about logistics about the hackathon, and it's also going to serve as a team formation networking mixer for teams to form together. So we're going to go through everything that has to do with the hackathon in today's meeting. So,
yeah, before we talk about a lot of logistics, we try to keep our events very special. We want everybody to be very inspired before we begin, competing against each other. I try to think of something relevant that I could talk about before we begin. I have this book that I've been reading. Anybody heard of Start With Why? Anybody heard that? Anybody heard of Simon Sinek? He's a known author, a very good public speaker. But in chapter 14 of this book, he talks about something very, very inspiring. I think I had to read it almost 3-4 times that I was very, very inspired by it. And it talks about this story of this person, and his name is Ben Coleman. Ben Coleman is participating in a race, and there's a lot of other people in this race. And Ben Coleman has cerebral palsy. Cerebral palsy is a neuro disease which affects your ability to move and coordinate amongst your body. And so this is a very inspiring segment that I wanted to read to everybody, and hopefully that can be an inspiring start to this hackathon. So Ben won't quit. The pack is now out of sight, and Ben is running alone. It is quiet. He can hear his own labored breathing. He feels lonely, and he trips over his own feet again, and down he goes another time. He grimaces as he uses all his energy to pull himself back to his feet to continue running. For Ben, this is part of the routine. Everybody else finishes the race in about 25 minutes. For Ben, it usually takes more than 45 minutes. When Ben eventually crosses the line, he's in pain and he's exhausted. It took every ounce of strength he had to make it. His body is bruised and bloody. He's covered in mud. Ben indeed inspired us. But this is not a story of when the going gets tough, the tough gets going. This is not a story of when you fall down, pick yourself up. Those are great lessons to learn, without a doubt, but we don't need Ben Coleman to teach us all of those lessons. There are dozens of others who you can look to, like an Olympic athlete who suffered an injury just months before the games, only to come back to win a medal. Ben's lesson is deeper. Something amazing happens about 25 minutes in. When everybody else is done running, everyone comes back to run with Ben. Ben is the only runner who, when he falls, someone else picks him up. Ben is the only runner who, when he finishes, he has hundreds of people running behind him. What Ben teaches us is special. When you compete against everybody else, no one wants to help you. But when you compete against yourself, everybody wants to. I think I wanted to mention this story because, like we saw in the room, everybody's at different levels. We've got professionals here, we've got first years, we've got no fourth years, but we've got third years. And we're all at such different levels. And this is obviously a competition where we have all of these prizes. But at the end of it, If you focus on competing against yourself, I think it's going to be a more enjoyable experience, not only for you, but for everybody, have the entire team here to help you out as well. So hopefully that's inspiring, and we get to the not story part of this hackathon, which is the business. Thank you.
Oh, thank you, Akshay. And I just wanted to give a more deeper understanding of what this hackathon even is about. So responsible AI, we all hear responsibility. What does that even mean? So what our hackathon is to really address is the development and the deployment of AI systems that prioritize ethics, fairness, transparency, safety, and accountability. The goal is to ensure that our AI technology benefits society as a whole while minimizing harm. So why responsible AI? AI is powerful, but that means we have to be the ones leading the goodness and outrun bad actors. We need to protect ourselves, make sure that we're complying with regulations and driving long-term innovation. But why now? We're at a turning point with so much AI in the news, so much development of new models, new agents, but we need to make sure that we're educated and putting responsibility, the human touch, and ourselves first. So us students, we're always going to be students, we're always going to be learning, and us curators, we need to ensure that we're the next line in this defense system. So we can't wait for regulation to catch up. We need to be the ones that are paving the path, the trailblazers in this process. So responsibility is a call to action, and it's something that we need to ensure that we're driving forward as we are the next generation AI leaders. So we can't wait to see everyone participate in this event, what you build, or just showing up to our AI summit. It is really all of us coming together to ensure that we are moving forward with good intentions in mind. So we're really excited to kick off this event, and that is what responsible AI means to us. Now, before we do that, I want to talk a little bit about the beginnings of Bruin AI, and I'll let our president, Ashita, talk about that.
Hi guys. Before we start, I just wanted to pose a question to you guys. Why are you guys here today? Let's see some hands.
Fear mongering in the current communication of these technologies.
Exactly. Anyone else want to share? I know we got people from like SD, 30 minutes away, Pasadena. Any stories you want to share? Yeah, so the really mission that captures Bruin AI is we are cool people who want to build cool shit. And then this room, if you guys see, it started from CLA. It's where all these companies you put behind were formed. Duffel, 5 minutes away in Engineering 6 is where the Uber founders sat there and discussed their idea for how to launch Uber. So this is really a launch pad. And this hackathon is a good start for you guys to really come together and build something cool. And Bruin AI is really the AI everything spot. We do research, we do events, we do projects, we do client projects with startups, with companies like Google and BCG, and really we just do cool things. And I hope you guys have a good time today. And yeah, thank you. I would love to invite our keynote speaker to kick us off. Yeah.
So I can let you connect.
Our keynote speaker is Shahab. He's the CEO and co-founder of Flakescale. And we'll be talking about the future of distributed compute. And we'll let Shahab kick us off.
I want to make sure that you're sharing
Yeah,
on Zoom. For the Zoom audience.
Oh, how do I
so
do
let me
that?
get you screen share. Are you on the Zoom meeting?
No.
Okay. Can I send you the code real quick? Or
Yeah, but internet wasn't working for me. How do I get on the
you can connect to UCLA Web.
Yeah.
Yep.
So we have a prize for somebody who guesses what food we have today.
I will say that it's rigged because I actually did before.
Okay.
Yeah.
And
Wait, Who all knows what the prize is already? What the
You
food is
save
already?
it.
You guys don't get to participate. Okay, everybody else, any guesses? Go ahead. Any other guesses?
I'm gonna guess it's Costco pizza.
Now he knows.
Any
you know.
guesses? Apart from the pizza, because it is pizza. Because it was so obvious, there's no prize for you guys.
Okay.
So you don't get to know.
Yep.
Does anyone
Screen
want
share on
that?
Zoom.
That's like the drinks that besides water.
Chrysanthemum tea.
Come on, comment down low.
He might.
If only we all paid so much attention to that.
Yeah. And then allow to share. I allow screen share.
Oh, yeah, perfect.
And you can just leave it on mute. Don't join. That's great. Screen share?
Mm.
Yeah, share.
What brought you to
PowerPoint?
I think I need to do this first.
Oh, no, you don't have
So,
to. Should be fine.
So I joined Bruin AI when
Sure.
there were 0 members
You
in
can
the
put
club.
present.
I'm the founder.
Oh, now we can see.
That's what I'm
And
saying.
we
Oh,
launched
sorry about
2 years
that.
No, you're good.
Here's
You're
the-
good. I think
And
we.
the entire mission was to
Yeah.
extend AI into the hands of everybody. At that time, ChatGPT had just come out, and so we saw this insane surge of people who
Did
were
you
trying to get into
still want
AI.
to share?
And we
Yeah,
didn't have
we can. I think we can do this,
ceiling.
right?
So the entire hope was to make a platform where everybody can come and participate in it. Yeah,
Sure.
now we're a big community. So
here.
This one.
makes me so happy.
Okay, sorry, technical difficulties. Hi, everyone. I'm Shahab, the co-founder and CEO of Lake Sail. Before we get started, I want to just get a feel of the room. How many people here are familiar with Apache Spark or distributed programming concepts? 1, 2, distributed compute, distributed AI. Okay, cool. That's good to know. I will do my best to break down the concepts a bit. So in this keynote, we will explore the current state and the future of distributed compute. We first start off with giving a historical overview of Spark, understanding that every major advancement builds on the learnings from the past. Then we dive into what Lake Sail offers by examining the technical details of the Lake Sail architecture and going over some key use cases. So at Lake Sail, our North Star is very simple: smart data processing smart AI warrants smart data processing frameworks. And there's really 4 principles here. AI models are only as good as the data they're trained on. Efficient data processing is crucial for high quality, timely insights. Traditional frameworks struggle to keep up with the data demands for AI, and scaling existing solutions leads to diminishing returns. We believe that better models won't just come from better algorithms, but by fundamentally rethinking how data is processed, scaled, and used to support learning and inference in intelligent systems in real time. So Spark revolutionized the big data world. It was created in 2009 Berkeley Amp Lab, open sourced in 2012, I believe, and fundamentally changed big data processing and fundamentally changed how the world knows big data processing. At the time, it was known for being lightning fast, being 100 times faster than Hadoop MapReduce. And today, Spark is the most widely used engine for scalable computing. 80% of Fortune 500 companies use Spark. But for people who work with Spark for distributed data processing, there are some known limitations of Spark, specifically around performance and cost. And so we have the big data challenge in the AI era and the hidden cost of legacy frameworks. Spark and frameworks like it weren't built for the world we're in now. There's system fragmentation, disparate data processing system with these AI compute frameworks, leading to developer inefficiencies and limitations in getting insights out of your data. Performance limitations. Spark's JVM architecture is known for high resource usage, sucking up CPU and memory, and then being a row-based architecture does not allow for columnar vectorized execution. And it lacks adaptability. Spark's 15-year-old design wasn't designed for the big data and AI heavy world that we're in today. Big data in 2009 is much different than big data today, right? And then cloud native mismatch. Spark fundamentally is designed to have coupled storage and compute, allowing for data to be stored locally and executed from a local source, rather than today's modern architectures have decoupled storage and compute where data is in S3, for example, and you can store an unbounded amount of data there. And then AI's last mile data problem, where it's notoriously difficult and hard to utilize data processing in the final steps of training for AI models. So if you use Spark, you've been using it for many years, most likely. Organizations all over the world have had or have built up a 15-year reliance on Spark. And so what if you could get the developer experience of Spark, the familiar SQL and data frame APIs that you've known and used for the past several years? What if you could preserve the parts that we know and love while reimagining the engine for the world we're in today? And what if you could run it all on a radically faster cloud native engine with zero code changes? Well, Lake Sail built it. Sail's a drop-in replacement for Apache Spark, fully built in Rust, which allows us to run 4 times faster than Spark at 6% cost. And our mission is to unify batch processing, stream processing, and compute-intensive AI workloads. We eliminated the JVM entirely, so no garbage collection, no garbage collection pauses, just smooth, clean, efficient system-level performance. And so when we want to look at some of Spark's pain points, we have JVM overhead and garbage collection, where Sail eliminates this entirely with zero cost abstractions, compile time memory management, meaning there's no just-in-time compilation, there's predictable memory usage, and there's no garbage collection pauses, which quite literally make your program pause. Serialization bottlenecks are gone. We leverage Apache Arrow's zero copy memory, zero copy columnar format that allows you to zero copy execution allows you to pass data across processes without having to do any copy of the data and just loading it natively, essentially, without any serialization or conversion formats. No more JVM tuning. So if you work with Java, you've worked with Java at a big scale, you've had to do JVM tuning. There's no science or formula to it. It's really unpredictable and painful. Now, the last thing that's really the most impactful is Python user-defined functions. So when you're doing data processing, there's a concept of user-defined functions where you have some isolated unit of code that has whatever logic you want that operates on some input data. In Spark, there's a bunch of really rich APIs for Python UDFs, but no one really uses them because of the limitations of the JVM. Running Python code in the JVM requires an isolated process to be spun up. All data that the Python code needs to be copied over and sent over into that process. So it's limiting in what you can do because you can't copy the whole world in one process. It's also slow for that same reason. So Lake Sail makes big data compute faster, simpler, and cheaper, 4 times faster than at 6% of the cost with zero code changes, meaning use the same exact Spark client code, and in the eyes of the user, really nothing changes. And of course, I wouldn't be saying all of this without the receipts. So let's take a look at the numbers. So what you're looking at is a TPCH benchmark, 100 gigabytes, 64 partitions. TPC stands for Transaction Processing Council. It's the industry standard or industry gold standard for benchmarking. And here Sail runs roughly 4 times faster on the whole benchmark of 22 queries. We look at speed up, comparing Sail to Spark on every query. You can see for some queries, Sail is over 700% faster. And at the end here, you can see the the least performant one is still 43% faster, and we'll see why. So this is total query time, and you see where there's less of a delta, like query 19, query 14, and query 6. That's because Spark ran those queries fast and couldn't really get much faster than that. And now we're going to look at resource usage. So on the right, you see sales memory and disk usage, very minimal memory usage, 0 disk spilling, meaning no data was written to disk. On the left, Spark's resource use is much higher. Memory usage is very spiky. Disk usage is very spiky. Memory usage peaks at 50 gigabytes. And you have to take into consideration when you're looking at 100 gigabytes of raw data, that's roughly 34 gigabytes of compressed Parquet data. And so Spark is using more memory than total size of data, and for some reason still writing to disk a ton. This slide speaks for itself, really. Starting a Spark cluster takes 4 minutes. A sale cluster takes a few seconds. I know in downtown San Francisco, I can get an Uber faster than 4 minutes. And so how is sale so much faster? Well, we've built it entirely in Rust. We've eliminated the JVM entirely. There's no garbage collection pauses. Rust offers system level performance. System level performance means it's essentially as fast as C, you're getting as close performance to hardware as possible. And the beauty of Rust is that it's memory safe, which is a blessing for data intensive applications. Memory safe means you don't have to worry about null pointer exceptions, memory corruption, memory leaks, any of that stuff. Modern CPU optimized, so compiling a sale binary will be optimized for the hardware that it's being compiled on. That allows for radically faster performance. Now we're going to take a closer look at sales distributed processing architecture. The guiding principle is simple. It's the same as the Go programming language. Don't communicate by sharing memory. Share memory by communicating. Do you have a laser pointer? Okay, I'm just going to point my finger. So here, you have the Spark client, PySpark client, doesn't really matter. All Spark clients use the Spark Connect protocol. Spark Connect protocol is a bunch of protobuf files, protocol buffers. So it's essentially a spec for an API. It's the entire blueprint of the client-server interaction. So use the same Spark client. Here we have Sale Connect server, and this is a distributed processing architecture where drivers will spin up workers based off of the demand, and it runs with the actor model and a single threaded event loop. So workers are spun up on demand. You have your workers here. There can be more than 2 workers. This is just an example. There could be 1 to 10 to 20 to 100 to 1,000, depending on the workload. Workers have many tasks. Tasks do the execution of the workload. And then we use arrow streams for shuffle data. So shuffle data you can think of as, if you have, I'm going to give a very dumb example, but if you have a PDF file and you want to turn every line in the PDF file to bullet points, and then you want to highlight those bullet points in red, let's say that's our job. So task 1 could maybe be going from PDF file to bullet points. Task 2 could be going from bullet points to highlighting, and so on. And so each stage of those tasks is shuffle stage. Now, this diagram shows how Sale integrates with Data Fusion to power query execution. Apache Data Fusion is an open source Apache project that provides query engine building blocks for data systems written in Rust. The green boxes represent functionality within the Data Fusion library. The blue boxes represent Sales extensions. On the left, point again. On the left, you have things like the SQL API and the data frame API. So that's going to be a Spark client sending a request to a sales server. We translate that request into a sales spec. we construct logical plans and we add extensions to logical plans. Logical plans are essentially the blueprint of physical execution. Once you have a logical plan, you'll get it optimized with a logical optimizer to kind of simplify and set a path towards the most performant execution plan. Then the physical plans touch physical data. So I call physical plans. They have physical optimizers as well, and they do the actual execution. So the driver will spin up the worker, as you see on the right there, and you see that the physical plan is divided into stages and parallelized as tasks across data partitions. The tasks are sent to the workers for execution. The data flows through the operator graph as a stream of arrow record batches, and you're building a DAG, so directed acyclic graph. In the previous slide, we saw sales distributed processing architecture, and here we know how query execution happens within each worker task. Now we're going to take a look at semantic analysis, how SAIL parses SQL with compile time confidence. The approach that we took, I guess let me take a step back to explain what semantic analysis is. If you have a query like select star from users limit 1, client will send that up to the server. Server now needs to build that into a logical plan somehow. And so that's what semantic analysis is, understanding that text and breaking it down into a plan, creating a DAG out of it and setting it up for physical execution. And the approach that we took is something called parser combinators. So we built SAIL SQL parser entirely from the ground up, entirely in Rust. Java has a bunch of libraries and other tooling to do this. Rust is fairly new in production across industries, so tooling is a little less mature. So a lot of things we have to build up ourselves. So going back to parser combinators are reusable building blocks. And so think of like the movies Transformers, when there's these little cars that make the big car. That's like the best analogy you can give to parser combinators, I think. Each parser is independently functional, but when combined together, they form a much larger, much more powerful system. And so each rule parses itself, meaning it's fully functional and compatible with its own set of rules. But you can form a powerful collective that together forms a complete SQL parser capable of handling complex queries. The entire grammar is defined directly in Rust using strongly typed structures. So that gives us a clean, abstract syntax tree first design where every SQL statement is parsed into a type-safe, structured representation understood at compile time. And here's the best part. We generate a lot of the parser code automatically using Rust procedural macros. Procedural macros you can think of as shortcuts to defining what code is. And so it's a templated code essentially. And so you can define a bunch of templates to do all the logic you want to do and call it with whatever input variables you want, and you get code generation. So rather than manually implementing the parsing logic, we build a solution that understands SQL the way a compiler understands code, with clean semantics, structural clarity, and complete control over how queries are interpreted. This gives us power to optimize, extend, and evolve. And so, for example, in the future, when we start supporting things like GQL, graph query language, we'll be able to do that with a bunch of flexibility. So let's zoom out for a second and look at how data processing has evolved. In the past, we had Spark and tightly coupled systems. These were great for their time, but had real limitations. Compute and storage were coupled, which made scaling expensive and rigid. Then came the rise of decoupled architectures, separating storage and compute. This gave us better flexibility, but even with that shift, we still do not have a compute framework that is designed natively for such architecture. Spark becomes legacy at this point. The JVM and row-based engines are not ready for today's workloads. And so in the future, we have SAIL. We reimagine Spark from the ground up, entirely in Rust, columnar data processing by default, and ready to handle batch streaming and AI workloads. This isn't just an incremental improvement. It's a reset on what modern data stacks look like. Now, since this is a hackathon and you're a bunch of students, here's my advice as a founder. Pick something hard, something meaningful, and something with a real moat. We're in a bubble. Anyone could see that. So build something difficult, build something real, ignore the noise. That's how you build durable value, by going deep, not by going wide. Don't chase the shiny stuff. Don't do stupid vibe coding bullshit. Just for likes or whatever. That may feel fun in the short term, but it rarely leads to long-term impact. So if you want to stand out, do the hard thing well, and keep going when it's not cool yet. And finally, if you'd like to learn more about Lake Sail or Sail, give us a star on GitHub or reach out to me directly. You can get my email from one of them. And I think we have 10 more minutes, so I'll open it up for Q&A if anyone has questions. No questions?
So you said that Sail is eliminating garbage collection. What are the trade-offs there, if any?
Yeah, so memory is managed at compile time, and that forces you to write code in a very specific way, or otherwise it won't compile, and the Rust-C compiler will yell at you. And so you have to start thinking about variable lifetime, and if a variable is short-lived and cannot be accessed downstream somewhere, then the code won't compile. Everything is very strongly typed. What else? Everything needs to have the same exact return type. So when you have like match statements or if-else statements or functions built through macros or whatever, functions based off of, what's the word I'm looking for? The word I'm looking for is functions based off of, I'm blanking on the word, which is okay, but you're forced to have the same return type.
Nice. Thank you.
Does that make sense?
Yeah.
Could you elaborate on that last point regarding do something hard?
Yeah, so I hope a bunch of people here are doing this hackathon because maybe they're interested in doing a startup. There's so much noise right now in the industry where you're seeing all these AI companies generate a ton of revenue really quickly with some stupid product, or all these ChatGPT wrapper companies. There's no moat there, and you're going to get a bunch of VCs who look like they have a very solid background, not know what the fuck they're talking about, and wasting your time. And so you'll often run into people wondering why you're not profitable with a fully built platform and product and vibe coding your way through it. That's quite literally expectation. So you got to shuffle through that noise. And you got to shuffle through the noise of all of these startups skyrocketing into all these crazy ARRs, right? Those aren't moats. Just as fast as they got all of that money, they will lose it just as fast, right? Does that make sense? The incremental optimization perspective doesn't work. Databricks tried it with Photon, and there's a very simple reason for that. At the core, you still have the JVM, and so you cannot reduce resource usage. There's a ceiling to how much performance gains you can get, but most importantly, there's only partial optimization. So take a look at Databricks, for example, and Photon. Photon can't support Python UDFs because most of the work happens in the logical planning, and something like Photon or whatever NVIDIA is doing is just doing the physical execution. And so you have to rebuild and redesign the system from the ground up to natively support, Python interoperability and native Python execution And so when you execute a Python UDF on Sail, Rust has great Python interoperability. It executes native Python code. There is no data copying. There's no serialization. There's no spinning up a isolated process that you have to pass everything into. You have access to the whole world of what the framework has access to, and you're able to do zero copy execution with Apache Arrow. And so I can give a little background on why we picked this path, if that would be helpful. Essentially, we started Lake Sail initially just as a business. We weren't going to raise any venture capital or anything. And our goal was to build a managed service for Apache Flink, which is a stream processing engine, because we didn't find any that existed. So we spent 6 months building it from June, July 2023 to January 1st, 2024. And we fully finished building the managed service. There was one thing that was really bothering me. Why is no one doing AI with Flink? It's a very natural use case. AI with stream processing gives a bunch of benefits. And so I went in a rabbit hole for like 2 weeks and discovered that on 2 separate occasions, Alibaba had tried to do so. One of the projects was called Deep Learning on Flink, and they abandoned both projects. And when I started looking into why, the answer is really simple. You can't execute Python code on the JVM in a way that's not limiting, in a way that's performant. The whole thing about the isolated process that I talked about, that was the aha moment. And so we ditched the managed service because we realized in 2024, you could unify data and AI workloads, while in 2009, Rust didn't exist, right? JVM was probably the best option that Spark had. Rust version 0.1 only came out in like 2015. And so when you look at something like Ray that came out in 2017, Ray's original vision was to unify data and AI workloads. They tried to do that in C. C is not memory safe, which makes it incredibly annoying to try to do so, to the point where Ray just gave up on it. But in 2024, where Rust is a mature programming language used all over the world, by Amazon and Microsoft, et cetera, and being memory safe, now there's not the limitation in programming languages that allows you to do something like this. Does that answer your question?
Yeah.
Anyone else? Cool. Well, that's it. Thank you, guys.
Thank you so much, Hannah. Now we're gonna talk about hackathon logistics as well as sponsorship highlights. So I'm gonna just share my screen for that.
So I guess all you guys here. Oh, sorry. My name is Hayu Chen. I was one of the hackathon leads. I was working on the hacker packet on the dev post. Also a little bit on the Luma side, trying to make sure everything's standardized, everything is consistent. Trying to get the prizes and all the information out to everyone. So I'll talk a little bit about the hackathon logistics, because I guess you guys are here for that, because that is quite important. So for the teams are 1 to 5 people. You can be solo, you can be five people. You'll make that choice on a form, and that we'll talk about a little bit later. But right now, we'll have a team mixer a little bit after I finish talking, and there you can find your team if you don't have one already, or you can find a team on the Discord, and we should have the QR codes for that in the slides later. I should mention that there's some people online right now attending this kickoff, and you can attend this hackathon virtually. It's essentially async. But of course, those people also have to make the video submission. I'll talk about what you need to include in your project submission on that post for this competition in order to be actually judged by our judging panel. Teams must be finalized by April 16th. That's next Wednesday. by 11:59. So hopefully by that time you should have your team, because that gives you only a little bit of time to really finish your project. And of course, like interrupt me at any time if you have any questions. Cool. Oh, it's cool. So if you're not joined on the Hackathon Discord yet, here's a QR code to join. I don't. Oh, okay, some phones coming up. Yeah. We'll also be announcing stuff like we'll be reminding you guys about any deadlines or any new things that come up, any challenges or whatever here. So maybe keep an eye out. Any more? Looks fun. Okay, cool. Also, the team formation form, this will be sent out on the Discord as well. Here's just the form for right now. If you already have a team, I'll also ask about whether you're participating in the challenge known as the Sentient AI Challenge. Also talk about, I'll also ask you like, which track do you intend on participating in? What project ideas do you have so far? It's just for us organizers to gauge like where everyone is right now. This is due Wednesday, April 16th, so you don't have to worry about it yet. But you should worry about it by the deadline. Okay. Also, just a little bit about our tracks, just to get you a little bit excited. Our first track is tech innovation and evolving workspaces. So we were thinking a little bit along the lines of stuff like Slack, automating workflows. How can we make everyone more productive in our workspaces and like stuff along those lines. We're also talking about sustainable infrastructure and green solutions. So UCLA also has a little bit of focus on environmental solutions, applying AI to like analyze data for climate change solutions and stuff along those lines. UCLA has a huge pre-med, biomed sort of community. So we have the healthcare, biotech, and data privacy. Data privacy might sound a little bit strange put into that track there, but this is more for along the lines of like, how are you safeguarding patient data? It's a very important consideration for responsible AI. Yeah, with typical requirements and the like. And of course, the last one, we're in Los Angeles, Hollywood. You know this field. Entertainment industry. What can you do with AI about like creative processes, making new projects and stuff? And also ethical content use, because as Studio Ghibli mentioned at some point, they did not like how we're using AI. They didn't like how we're co-opting AI for Studio Ghibli styles. So we also need to make sure that we're always properly attributing where our training data comes from. Cool. Yeah, and also all this information can be found in multiple places, but another place where everything is aggregated is the Hacker Packet. Please do check this one out. This one is like the most comprehensive, I feel. This also has the Discord, the workshop sessions, what's happening at the conference, stuff like that. Also, it has the contacts for everyone here, like on the Bruin AI team, if you want to reach out, ask questions, if you're struggling with team formation or have any questions, you can also ping us in the Discord. Find us at the email. Yeah. Right. Prizes. 4 tracks. Each track winner receives $250 worth of Oxygen AI credits for whatever AI compute you want to do online. Also, you get, this is probably more interesting, but your VC pitch with ParaVC, or a VC at ParaVC, and they were one of the early backers of DoorDash, Guardian Health, and Gusto. So you get the chance, if you build a really meaningful product, and that's why we're also emphasizing meaningful products. So you get the chance to pitch to ParaVC and see where that goes from there. Also, every hackathon team that submits an actual genuine project following our guidelines will receive 1 month free subscription to WarPro. So that's like terminal autocomplete for those that do that. And also free tickets to the SAIRS 2025 conference. That's next Saturday. Also a lot of really cool speakers there, NVIDIA, Microsoft, stuff like that. So free tickets, pretty awesome. Also free food. Yeah. Your team may also submit to the Sentient Chat Agent Challenge, which if you do win that, is $500 in cash. The requirements are listed in the hacker packet, and I believe we have someone on the Zoom to talk about that challenge from Sentient. Yeah.
Yeah, so we're gonna give a second for Sentient Chat AI to talk about his challenge. And yeah, so let me just pull that up.
Hello. I'll just share my screen.
Is Ben on this call? Hello, hello.
Hello.
Hi.
Can you guys hear me?
Yeah, let me see if, can you share your screen?
Yep. Everyone able to see that?
Yeah.
Well, hello, everyone. Great to see you all. I'm Ben. I'm here representing Sentient. We are very excited to be offering the Chat Agent Challenge as part of this hackathon. Just super quickly, Sentient's goal is to really enable AI development for different communities and like kind of more like different niche applications, but in a way that it really serves those communities and is loyal to those communities. At the core of how Sentient does this, at the core of Sentient's mission is this product Sentient Chat, which is ultimately our chat platform. You can think of it kind of like ChatGPT, but it features kind of sentient products, sentient models, and very importantly, is our core platform for community agents, where kind of different curated actors can work with Sentient to build agents to put on this platform, similar to like GPT Store. But in Sentient's case, soon these agents will have considerably more capability because unlike custom GPTs, these agents run independently, are called by API, and will soon to be able to be monetized. At the moment, Sentient Chat has a 1.8 million user waitlist, and is only serving like a very curated selection of agents that we've worked with different companies and startups to integrate onto the platform. Right now, we're looking to try to find top talent to add to this curated selection of agents. And through this hackathon, we're giving you guys all the opportunity to build an agent that would be considered for integration into Sentient Chat and getting very fast distribution, kind of very wide usage. To participate in this challenge, all you have to do is build any chat app. For now, you don't have to make an agent that we can directly integrate into Sentient Chat. You don't have to host it as an API. You just need to have a chat app either as your whole project, part of your project, or it could even be something that is somewhat adjacent to your project, but you submit in a separate link that, or in as a separate GitHub link in your final submission on the final submission form. And for this submission, you'll have you can kind of implement this any way you choose. It just has to still be aligned with the track that you chose for the competition, and it still has to fit within the competition themes. But you can implement this agent any way you want. You do have to have some kind of UI that we can use to try interacting with your agent when we are evaluating all the different submissions to see who wins. In terms of prizes, we're offering $500 in cash for the winning team. Potential for this Sentient Chat integration, which I think is the most exciting of really the most exciting prize here. And then also expedited admission into the Sentient Builder program. Right now, as we're trying to ramp up community involvement in developing these agents, Sentient is offering $1 million in builder resources through the builder program. Anyone who does well in this hackathon would be very much a top contender to get into this program. So yeah, we're very excited to see what you all build. If anyone has any questions, feel free to reach out to me. There's a link to like the details for this challenge in the builder packet, and on that link on this challenge Notion page, there's contact details for reaching out to us. We're also going to be hosting office hours at 2 points this week. Details are also in the builder packet. We're happy to provide support in like explaining any questions you might have about the challenge, help actually building whatever you're trying to build, or just support in any way you guys can provide or we can provide. But yeah, that's the challenge. Good luck, everyone.
All right, thank you. Thank you so much, Ben. Now we just have a couple more slides to finish up regarding speakers and our week of events. So you want to continue off?
Yeah. We want to finish up with project submissions. Sorry. So for project submissions, it's quite important. You need to detail a short project summary. If you've seen that post before, you've seen like some pre-hacks, LA hacks, have a little write-up of what you did in your project. We want to make sure you know what you were doing. You know what you're doing. We just want to see it in words. Less than 1,000 words, you probably don't need more than that. You want a GitHub repository or a live demo link where you want other people to be able to see what you built, what kind of features you can integrate in. Yeah, just try out your product. And also, because this is somewhat VC, there's one of the prizes, or also the judging aspect, we have some VC there. We want you to make a 3-minute demo video and pitch. So generally what we're thinking about is you would make a slide deck. You don't have to share the slide deck with us. We'll see it in the video. You present that slide deck. What are the features of your app? Who are the users that want to use your app? What kind of problem are you trying to solve? We have more details about what you should include in your video on the hacker packet, but generally you should say that stuff. And then also demo your product in the video, right? We just talked about the sentient chat agent challenge. If you want to participate in that, that would be a supplemental GitHub repository.
All right, thank you. So we have a really cool lineup of events. Some of them are actually going to be our conference speakers, including Anita from Microsoft. We also have Michelle from Xbox. So please chime in. All these links and details are in our shared calendar, which is also found in the hacker packet. And our workshop timeline, this is going to be shared over as well. Just to give you like a brief overview, we have something every day this week. And obviously we have our conference in a week from today. And just a little bit about that, we are aiming this conference to have expecting over 600 participants and industry leaders, including NVIDIA, Google, Microsoft. And yeah, just please come out. There's also going to be food, Mr. Noodle. So it's going to be a really, really nice event. And as well as there's the research competition showcase. And we're also going to be announcing prize winners for the hackathon. And here are some of our sponsors for our conference and hackathon. We'd like to give a big thank you because without any of them, we would not be here today. And this is everyone that has helped on the team. It's not a full list, but it's just a couple of highlighted members. And yeah, I'm super thankful to be a part of such an amazing team. So without further ado, we're going to get into our team mixer formation aspects. And we also are here as a resource to answer any questions. And there will also be food coming very, very soon. Do you have details about that?
Yeah, I know it's really, really hot in there, and I know you guys are so excited to start forming your teams. We actually have pizza already out there, so if you guys want to step out and have like a social mixer near the stairs, I know it's really hot, so cool down there. But before you guys leave, if you guys have any questions you want to ask right now, this is a good time to come in. everyone wearing a Bruin AI t-shirt, come to us to ask me the questions. If not, get some good pizza from out there, and then we also have tea and water there as well.